This here is an industry standard luggage trolley. Kind of wobbly, kind of bulky. This is the Peak Design luggage trolley. Isn't that nice? Let's have a look. If you're not too familiar with carbon fiber luggage trolley assemblies, that's okay. Let's figure this one out together. I'm Rob J. I'm a mechanical designer here at Peak Design, and I've spent the last 4 years working on this here roller luggage and carbon trolley. If you have a look inside the bag, you can see the trolley tubes, but they're incredibly flat compared to other luggages, and that's going to intrude on your packing much less than other bags. The goal was no tubes showing inside the bag. A slightly impossible goal, but we did everything we could to minimize the stack of the trolley into the bag. The boss wanted 0 thickness. Did my best to get there. One of the major benefits of our trolley is the low profile nature. And so we have an outer tube that is aluminum that houses the whole assembly mechanism. And then importantly, the inside tube here is carbon fiber, and you can see it's extremely thin, and we couldn't do that with aluminum because it's just not strong enough. With carbon fiber, we can orient the strength in the direction that we need, which would be in the bending direction here, and we can make an incredibly thin tube. Beyond the thinness of the trolley, there were a couple other feature improvements that we were looking to make over a traditional trolley. And one of those is the tightness of the trolley. How does it feel when you grab that thing and you drive your bag around the airport? Is it responsive? And as I think you've seen, many trolleys are quite wobbly and just sloppy up at this top position. And so a couple of things that we did to basically make that much better is, one, you can see we only have one tube section. It's this one single long trolley tube, so there's only one joint here. And so that minimizes the slop already. And on top of that, difficult to see, but this carbon fiber tube is ever so slightly tapered from top to bottom. So at the top, it's a little bit thinner, and then at the bottom, where the joint is at full extension, it grows and expands. When you deploy it fully, it expands into the bushing in the joint here, becomes more rigid and stiff, and that results in direct translation of force. When you grab this handle and you handle your bag in the airport, it's very responsive. To further enhance the responsiveness of the trolley at the handle, we thought carefully about how do the tubes connect to the handle and how do we make that more rigid. And so if you look carefully, in the center section here, there is what I call the handle chassis. It's 6061 CNC billet aluminum structure that directly connects both tubes to the handle. And so when you push in one direction or the other direction, there's 0 slop between the handles and the tubes. And so that also results in just a very responsive feel, and also just a tight assembly that it kind of sounds like a high quality car when you open and close the door compared to other trolleys. Here's the aluminum handle chassis, if you will be able to see. Most subcomponents of any trolley in another bag is almost always plastic and is intentionally made to assemble loosely to absorb the assembly tolerances and like the potential problems that you could have with function. And so that's why most trolleys, when you feel them, this is like slop, slop, slop in every direction. And so you gotta rotate your hand 20 degrees before you engage the bag to actually maneuver it. And so that's what is so strikingly different feeling when you grab the handle of our bag and you maneuver that thing. It's like a little go-kart zipping through the airport. It's like a race car part. The button is a primary touch point of the trolley here, and we wanted to make sure that that is a great experience to handle with your thumb, up and down. No slop, just a beautiful, beautiful sound. This is the button assembly. So it's a shaft and hole assembly, which any engineer knows this is basically like the best way to make a tight translating assembly, because you can control the shaft diameter incredibly tightly, and you can also control the hole diameter incredibly tightly. And so this thing slides up and down on this shaft with almost no slop, and that's what results in a nice and tight feeling button. Yeah, I still don't understand the driftwood. I need to talk to Fed about this. We just catted up the handle and he was like, make it smoother here and like curvature continuity, blah, blah, blah. And I was like, all right.
Somebody say driftwood? Hey, Rob, I can talk about that. What's up, everybody? All right, I'm sure you guys heard about all the engineering challenges that were overcome with this product, but I want to talk about the physical design and the industrial design involved with this one. So the affordances for this product were we needed to make a handle that was very comfortable in all directions, that you can grip for a long time without your hands getting tired, and that it also had visual cues as to where to press the button. So some of those cues were this little ramp down. It kind of guides your finger as a little lead-in, and of course the very nice feedback and audible cues that you get when you press the button. So in order to kind of get this shape correctly, I was very inspired by nature to kind of nail the curvature. It's extruded and flat in one direction, but very well shaped in this direction. And a lot of that shape came from my nature walks in Sea Ranch, where there is a lot of driftwood that has been constantly shaped and smoothed over time by the waves. These two, if you want to grab them, have that exact curvature to them. So a lot of inspiration from nature went into the design of these products. A little bit of biomimicry there.
It was a lot of work. This entire bag is designed from the ground up with custom parts, for better or for worse. It took us many years, and other companies maybe could come to market faster with a bag, but this is a special bag with a special trolley.